As I'm recording this, the James Webb Space Telescope is nearly 75% of its way to its destination, the second Lagrange point. There, it will give us an unprecedented view of the universe. Orbiting at this point keeps James Webb nearly stationary relative to the Earth and the Sun, allowing continuous 24-hour operations. Hours are the currency of James Webb. A quick scan of a patch of space might only cost an hour or two of telescope time, while a deep stare into an exoplanet's atmosphere could cost dozens of hours. The control of this currency lies with the Space Telescope Science Institute. They operate computers which talk to the Space Telescope and determine where James Webb will look. There's no saving the best for last here. James Webb is only planned to last 10 years, and none of that time is guaranteed. To ensure the right observations are made, the Space Telescope Science Institute created a James Webb Time Allocation Committee composed of astrophysicists and astronomers who judge observation proposals from scientists. The proposals are anonymized and sent to the committee for them to pick out those most likely to change our view of the universe. The selections, exactly what James Webb will look at in its first year of operations, are posted on the Institute's website. The link is in this video's description. It's an absolutely fascinating list of soon-to-be-answered questions, but there are some questions that stand out to me. In 2016, the Spitzer Space Telescope looked at a red dwarf star only 40 light-years away for nearly 500 continuous hours. From this deep gaze, 7 rocky Earth-like planets were discovered orbiting that star. All of these planets are thought to have water, and 3 of them are within the star's habitable zone, likely having liquid water. These alien worlds are the closest to Earth that we've found. Scientists are eager to determine just how Earth-like the atmosphere is there. 5 separate proposals for studying this system made it to James Webb's first-year schedule. The telescope is about to spend around 100 hours zooming into the atmospheric makeup of these worlds. If James Webb finds signs of alien life, it's here you should place your bets. But as exciting as that would be, signs of life will be just that. Signs, not conclusive evidence. And while I will be extremely excited with any discovery that points to alien life, the scientific community will want more before declaring alien life confirmed. NASA scientists recently published a paper detailing a responsible scale on which to judge evidence of alien life. At the bottom is the detection of a signal known to result from a biological activity. And at the top are independent follow-up observations of predicted biological behavior in the environment. Detecting oxygen or methane in an alien world's atmosphere would get us on the scale. Detection of unnatural pollutants in the atmosphere might get us halfway up. But atmospheric changes take time. It's very unlikely that alien life will be conclusively established by looking at a planet's atmosphere, at least in the first year of observations. But there are other places James Webb will look, ones where we may be able to ring that bell at the top of the scale faster. As we continue to learn more and more about objects light years away, one might expect that we already know everything about our own solar system. Surprisingly, however, there is still much to be gained from studying other rocks bound to our sun. Case in point, Uranus and its moons. Only one of humanity's space probes has ever flown within camera range, Voyager 2 in 1986. That probe discovered 10 previously unknown moons there. 2 more were discovered in 2003 by the Hubble Space Telescope. Neither system was able to determine the conditions on these moons with the detail James Webb can. And we will soon get that level of detail. The telescope will examine the atmosphere of these far-off moons, potentially finding signals of exotic, organic, ammonia-based life. If signs of exotic life are detected there, or anywhere else in our solar system, we will again stall out about halfway up NASA's scale of alien detection. That is, until NASA puts together a spacecraft to visit these moons and independently confirm the results. The discussion would quickly change to, is this life intelligent? The NASA scale doesn't even attempt to address that question, and determining if an alien life form is intelligent poses many challenges. However, there is a chance, albeit small, that James Webb will give us the immediate gratification we're all looking for. James Webb will give us a deeper and clearer image of our universe than we've ever seen before. It's possible that this new view will expose things that we've never thought to look for. Results in this category would be by far the most exciting and most likely to change our views. Perhaps we'll stumble on a faint signal encoding information being emitted from a surveyed star. Maybe we'll see trails of energy indicative of warp-speed intergalactic highways. We might even find alien probes lurking in our own solar system as we scan local space for potential Earth-destroying comets. I am eagerly awaiting answers to the questions we have, and for more questions to come up. The wait will continue until at least June of 2022, at which point all calibrations will be complete and science observations will commence. We may have to wait a bit longer to hear the results of the accepted studies. Although we know the list of observations James Webb will make in its first year, they don't seem to publish the order, and analysis of the data will take some time. But I have a feeling it will be worth the wait. I'll be keeping tabs on what James Webb sees and on other stories that shape our understanding of the universe. Consider subscribing to join me in this journey. Thanks for watching.